This is for the video instruction manual for the water balloon bomb release Pylon. It's a 3D printed kit. It consists of 8 pieces, 7 of which are shown here. I'm going to point out the parts. There is the lower pylon here, upper pylon here, pylon mounts here and here, the 2-part linear gear, and then the servo mount. Alright, there's also an additional part depending on which servo gets used. This kit was designed to use the 9-gram mini servo. This is the Tower Pro micro servo, 9-gram with plastic gears. This one is the Metal Gear MG90S, and the 3D printed gear for mounting on the servo is taller this way. It's taller than the gear for the plastic servo version. Okay, so I don't know which one of these you may use. I recommend the 9-gram servo. It's what the design or the mount was designed to fit. And the Metal Gear servo is slightly heavier. I'll be using the plastic geared version on this kit. Okay, and this is a Pylon meant to drop a water balloon bomb. This is a 3D printed water balloon bomb completely assembled. This is the Mark 64 version. And there's also a what I call egg cup version, which is right here. This is a lightweight version. The water balloon goes inside what I call the egg cup here, and the back of the water balloon passes through that slot right there, and the little tab that's sticking out of the end holds the balloon in place. So this also fits onto this drop pylon kit. So we've got 2 types of water balloon bombs. Okay, now the hardware that's required. This centers around an M3 by 20 millimeter screw. This one here. I have a multi-kit here with a lot of different sizes. And you'll also need M3 lock nuts. So lock nuts M3, 50 pieces. In addition, you'll need a 0.72 brass rod, K&S Precision Metals, number 8169, or as I like to use, the Dubro 256 by 12-inch threaded rods, and that's catalog number 801. Okay, now the threaded rod, this one, has already been cut down and used. The thread is only on the end. It's for threading on a plastic clevis for a push rod. And I used this particular piece of metal for fitting the grooves in the pylon. Need to be cleared out. You can see some stringing across that one. This part of the groove is fairly clear. The grooves are oversized to allow the metal to slide back and forth when the unit is assembled. It needs to slide freely. Okay, so I'll show more particulars in a minute, but that's an overview of everything necessary. Threaded rods or brass rods for the slider. You'll see what that is. That's the linear gear. Slides back and forth on these interior rails. You'll need 2 M3 by 20 millimeter screws and 2 M3 lock nuts to put the whole thing together. For attachment to your airplane, I'll leave the screw size up to you. There'll be 2 screws, one on each side of the pylon, that'll mount into your airframe. Okay, that's an overview of the parts. Next, we'll get on with the building. Excuse me. 0.072. Alright, so the brass rod or the steel rod, doesn't matter which one you use, as long as the dimension is correct. Alright, so I'm going to start with the upper pylon half, identified by the large rectangular opening, and this piece is flat entirely along the long end here. And so I'm going to start out on my piece of sandpaper. What I'm doing is a figure-8 lap cut, making sure that it's evenly sanded all the way around, and it doesn't look flat enough yet to me. Okay, that's a lot better. It's mostly flat. I still see some shine around the edges up here, but most of the surface is now a dull blue color. Okay, so I'm going to take a round file now and see, I'm rotating the file inside the hole as I move around, and that deflashes the edge. You can see I've got a little bit of blue there. Now I have another round file that's more of a needle point, and you can also use that. Now, just as a note here, I use a rotary tool often with carbide bits or mill bits. It makes it a lot faster and a lot easier, but sometimes you can't beat a jeweler's file for what needs to be done. Okay, like for instance, I see a flat right here that's not supposed to be there. I'll use a rotary tool bit to round that out. That'll need to be round for the lower pylon piece to fit. Well, maybe not. Look at that. Fit pretty much right off the bat there with just that bit of work. Okay, maybe I don't have to rotary tool that out. Okay, these slots right here are the guides for the slider rods. Oops, wrong end. Seem to do the job though. Okay, see that bit of string right there? That has to be taken down. I want to open these up and make sure that the metal rods are able to slide through these openings. Well, that's strung out pretty bad right there. There we go. Okay, now I prefer to do this part by hand by using a jeweler's file. And I can also just clear out any strings or high spots that might be in this opening here. Okay, looks pretty good. Now there's a indentation on one side. See that? Turn right there. I'm going to take a flat file and clean up that space. That is the opening for the servo mount to fit into. Now the servo mount has to be cleaned up as well, but it looks like we've got a pretty tight fit already. That's where it'll go. Oops, backwards. There we go. Actually, let's do this correctly now. The servo mount faces the outside, not the inside. That we'll put on later on, but wanted to clean up that space. And then the rest of it, cosmetically, you can do what you'd like with it. I'm just going to smooth it out a little bit. This part is actually not necessary to the operation, but as far as aesthetics go, it's a little bit cleaner. I'm not going to be painting this part. This is strictly a operational piece of machinery from my point of view. And unless I was putting it in a scale application, I don't need to paint it. As usual with anything being painted and assembled, if you do paint it, make sure that it doesn't interfere with any of the movement. The paint doesn't get into the rail slides or anything like that. Okay, now here is the lower piece. Now I cannot put this onto my flat sandpaper block because it's got these raised alignment tabs on there. So I'll go over it with a flat file just to make sure there's no flash on these raised dots. We already know the parts fit together because they accidentally fit right off the bat. And let's see, needle file, go through and make sure that these slide slots are clear. There's some stringing in this one. Need to break those out. Okay, that one's being a little bit stubborn, so just going to have to do this the old-fashioned way and file it down until it becomes less stubborn. And it's extremely critical that these slots are clear of any obstructions. There we go. And of course we'll test that during the assembly process. Luckily these parts, they don't get glued together. The top and bottom pylon halves are held together by a set of screws, one on each end. Can't fit that. Alright, well, that'll do for now. So we've got the upper piece and the lower piece. Let's put these together properly. Oops, not. Here we go. Alright, and then the old Mark 64 here. Okay, that fits. Comes out easily. There's no obstruction. Excellent. For the next step, we're going to pick up the two parts to the linear gear. Okay, so there's a flat print with the gear teeth on it. And then there's this part here with two grooves in it. And these are going to be glued back to back. So I want to make sure we have a good fit. So I'm going to sand the backs of both of these the figure 8. That gives me the flattest possible hand sanding. Okay, that looks pretty good. And next is this piece. I'll grab it by the teeth. All right, that looks pretty good. Let's put these two together. All right, that looks good there. All right, so I am going to grab some CA glue here. Let's put a nice drop in the center. I'll take my round wooden toothpick and spread out the glue. Careful not to get it onto my fingers. Okay, I'm going to use this wood board here to kind of slide the pieces together to get that glue to spread out, but also make sure that's aligned. Looks pretty good. Okay. So that should put the teeth right about in the middle of and I'm going to let that glue set. Now that the glue is set in this piece, I'll take my needle file and make sure that there are no strings or obstructions in the slots here. And one of the tools that I use here, you have to excuse the shaking, please, because my floor here is kind of bouncy. So when I move, the camera moves. Okay, I've rounded the end of this last bit of threaded rod end, and I use that to check the slot. So that end of the slot's good. That end of the slot's good. Now as long as the metal disappears all the way inside this slot, that's what I want. Okay, if we don't get it there, got to clean that side out. There we go. That side's clear. This side's clear. My threads, where the threads start to enter the slot, they're wider than the slot, so that doesn't work. But as long as I look at it from both sides, all right, there we go. I should probably clear out this side a little bit more. Seems to be an obstruction in the center there. It's still there. That's where the rounded end on this piece of steel comes in real handy. Because if I push it like this, and I can feel an obstruction. Okay, sometimes all I have to do is rub the slot a little bit and the obstruction will go away. All right, looks good. And we're ready to move on to the next item. I'm going to clean these edges up. This piece moves inside of a space. So you want to make sure that the edges are nice and flat. So they don't obstruct the motion at all. I like having this sandpaper glued onto a piece of wood because wood's heavy enough that when I do a light sanding job like this, sandpaper's not moving, it's flat. I use 3M spray adhesive to attach the sandpaper to the wood. I've been using this for a couple years. It's a little worse for wear and corner in a couple spots, but far outlasts sandpaper wrapped around a sanding block and is much more precise. Okay, I'm going to check my fit one more time. Looking good. Okay, now we're going to use this bottom pylon piece for fitting purposes. Got to make sure that this slides back and forth. It's actually going to be riding slightly above that surface once we get the metal rods installed. And I see a little bit of debris there that I want to take out. And we'll go over these pieces as many times as required to get them to operate smoothly and look smooth. If they don't look smooth, they probably won't operate smooth. Okay. There we go. So this piece now slides back and forth nicely, and we put this on here. Oops. We see the piece slides inside. It'll be slightly raised once we have the metal rods attached. But this is good. That's what you want. Freedom of movement here.